Hi guys, in this video we're going to talk about integration, but before we do that, let's revise a bit on the basic idea of differentiation. Okay, we know that the sole purpose of differentiation is to find a slope, right? Is to find a slope. So if you can see here, for example, this x to the power of 3 chart, you'll see that there's that is quite curvy, and to measure the slope, okay, the slope for this area is different from the slope of this area and other area also. So to find the slope, we can't really just get the difference between 2 points. So because if you are taking the difference, let's say from 0.6 and 1, we are going to miss out all of the minor differences that we have along it. So instead of just subtracting between two major points, we'll need to actually we should subtract all of the small points that we have along this curve, which is not really easy to do. So that's why we have the concept of dy dx instead of just the differences of y over differences of x. So this concept holds the idea of limitation, where the differences on y and differences on x is actually approaching 0. So instead of using this notation, differences in y and differences in x, we are using dy and dx. Okay, that is and by using this, we will produce a straight line that later can be used to measure the slope on each point, literally each point that we have in the slope. Right, so this formula or this idea is a lot more sensitive in finding slope compared to this, so and effective, right? Okay, so that is on differentiation. Now let's look on integration. What is the purpose of calculating integration? Okay, the most common definition that we have in integration is that we conduct integration to find the area under the curve. Okay, now talking about the curve, which curve? Okay, we have curves here, but the curve that we are talking about referring to the curve under the curve that is on the horizontal level, which is based on x. Okay, so when we are, because you can see this, if it is just if it is x squared, let's say x squared, and the curve, it is quite we can say that it is quite obvious that this will be the area that being measured, right? This will be the area that being measured by integration. However, if it is to the power of 3, like what we did just now, then where is the curve? Which area that we'll measure? So basically, you will see later that we'll still measure it with respect to x. So we have x line here, and when we conduct integration and we'll measure the area will be referring to the area under this curve to x. As for this one, it is above this curve toward x. That's why later you'll see that when you calculate for this one, you will get an area that is in a negative value, but the negative is not really, you don't have negative in area, but that negative represent the area that is below this x-axis, right? We can imagine it like that, right? If you calculate it for this one, you will get an area which is in positive value. Okay, so talking about calculating area, how do you calculate area? Okay, how do you calculate area? So let's say we want to calculate the area from 0.5 to 1, which is this area. How to calculate that? Okay, one way of course is to by looking by subtracting the value of y and x. Again, finding the difference. So if you just look at the difference of x here, so 1 minus 1 minus with 0.5, you will get 0.5. However, this 0.5 is not accurate because it is exceed this curve. Another way is to subtract a small portion, which is 0.5. You have a point here. Let's try to, okay. So by subtracting a small portion, right? So you have this point and all of these small points here. We're going to subtract this to 0.5, and you'll get these differences. And you subtract this point to this point, you'll get these differences, and you'll get the idea, right? However, it is still not accurate because they not really measuring up to the curve, right? To get an exact area, we'll need to, firstly we try to measure using the major point, which is not accurate. If we try to minimize it, yeah, it is a lot more accurate than the first one, but still will leave a spot, right? Meaning that we need to try to find need to subtract. We need to involve all of the minor point in x, which is we need to zoom in, and you see we can actually subtract a lot more points, right? And we can get a lot more accurate area for this curve, but still we still have a lot of point that need to be covered. So the idea is we need to zoom it more. As we zoom it in, we'll get more smaller points, more minor points that we can use to subtract, and the area will be closer and closer to the actual area that we have on the point that we want to measure before. Okay, so basically the idea is almost the same as differentiation, is that you cannot just use the major points here to subtract and get the area. We'll need, right? So basically we can't just find the difference of x because it is not accurate. We'll need to zoom it in. When we zoom in, right, it is too small until the difference will approximately, will be near to 0, and this idea applied. So instead of this, we'll use the x. So just imagine that you have all of the differences, the x of this function. So to find the area, we'll just need to sum it, right? So in integration, the notation of summation is the integrand, which is this, right? Just like s. And then this the function that we are discussing now is x3, right? x3. So we can put down x3. All right. And then what do we actually sum in this graph? We are summing the small differences in x, or dx. Hence we have the equation of integration. Okay, this is what does it mean by this. Okay, so the next thing to do is to actually be familiar with the integration formula, okay, that you have in our books, which is this. There is a whole bunch of it, but some of it can we can just use the idea of differentiation and just revert it back, and some of it you will try to find it. I'll try to see how to remember it. Okay, but remembering it is not the major thing, the point that I want you to do now. The most of the thing later will be prepared. You'll just need to be familiar with it. Okay, so right, some of the properties of integration that you need to know is if it is constant, then we can leave it out just like derivative, so that it will be easier for us to integrate later. And for summation and subtraction, if you have the summation and subtraction between two functions, the integration, you can split them up. Okay, that is on constant and integration, on summation and subtraction. We also have later some other properties, or some other method in dealing to deal with integration when it comes to other situation, right? But let's stick on this first, the basic idea. Let's look at exercise 4.11. All right, for this question, it is actually the summation between two functions, so we can split it up first. Okay, so split it up, and we see that we have a constant here. We can pull it out, and after that we can proceed with the integration. Now, integration, for the idea of integration that have this power function is that we will, instead of subtraction in derivative, we will sum it with 1. So 3x negative 2 plus 1, which will become negative 1, and later we will put the value of power after summation as a denominator. All right, so we have negative 1 with and another negative 1 as a denominator. So this is how we write it down. And as for this one, right, we don't need to integrate 7. It is outside the integral. So we just integrate sine, become negative cos. And don't forget to put plus c here for the case of indefinite integration, so where we don't really have a value at this integral. Later you will see that we also have definite integration, where we'll need to actually calculate the value that we have here. So for the time being, don't forget to put c, and we'll discuss later why do we have c here. So that is the answer for the first one. And for the second one, as you can see, we have the summation between three functions. So we split them up, and we do the same thing, which is we integrate this, right? This is just a constant, but when we do plus 1, we'll get 2x, right, over 1, which is the power of this x. And this is x plus 1, we'll get x squared over to the power, the same value, which is 2. And for tan x, the integration is equal to ln second x. And don't forget to put c. Alright, so, and this is the answer for it. Okay, so thank you.